Hello, everyone. We're going to be talking about accumulation and definite integrals in this video. This is lesson 8.3. We'll be using the Metropolitan Museum as our application. So the Metropolitan Museum of New York City, otherwise known as the Met, is the largest museum in the United States with almost 7 million visitors per year. The Met opens at 10 a.m. and does not allow any more entries until after 7:30. Any more entries after 7:30 and at 8 p.m. the Met officially closes. The rate at which people enter into the Met is measured by this equation. For the first 9 hours, this is open since time 0 is equal to 10 a.m. and time 9.5 is 7:30 p.m. and time 10 is 8 p.m. At what rate are visitors entering the Met? At 11. So 11 is time 1. And so all this is just wants to know what the value of the equation is at 1. And so plugging in, we get 2 minus 48 plus 288, because plugging in 1 is easy. Squaring it's no big deal, all that stuff. And that ends up being equal to 242 people per hour. Okay. So next, how many people have entered the Met between 10 and noon? This is the integral because we want to know what the accumulation is from 0 to 2 of m of t dt. I can integrate this very straightforwardly. I'm going to go ahead and go a little quickly. It's going to be t to the 4th power, and that'll give me over 4, and 2 divided by 4 is 2 in the denominator. This will be t to the 3rd, and 48 divided by 3 is 16. This will be 288. This will be t to the 2nd, and 288 divided by 2 is 144. And so I'm going to evaluate that between 0 and 2. So I'm just going to go ahead and plug in 2 to all the problems, subtract 0 plugged into all the terms, and that will give me 456 people. Okay. And if you're having trouble getting that answer when you plug in, just go a little slow. If you didn't simplify your integration, that's fine. Just make sure you go slowly as you do it. Between 10 and 4, at what rate do people enter the Met on average? So since it asks for an average, I'm going to go ahead and scroll up a little bit so I have some more room to write here. It asks for an average between 10 and 4. 10 is 0 and 4 is 6. So we want the integral from 0 to 6 of m of t dt. And to make the average, which we talked about in lesson 8.1, we do multiply by 1 over 6 minus 0. And we are going to integrate. We're going to get the same integral. And we'll end up with 1/6 times this integral evaluated from 0 to 6. So we'll go ahead and plug in 6 first. 6 to the 4th, excuse me. Minus plus 144 times 6 to the 2nd power minus 0, because when I plug in 0, I get all zeros. And that is equal to 396 people per hour. If you're wondering how I'm doing these calculations so fast, it's because I already did them all, and I'm just writing down the answers from doing them previously. It would normally take me quite a bit longer, but I don't want to waste your time. All right, so that's all the stuff about coming in and what we could expect on just straightforward there. And then in number 2, it says the people leave the Met at a rate given by this equation. And so, and that's from 0 to 10 because, of course, it's open. People leave until 8. Is the number of visitors increasing or decreasing at 2? And how do you know? And so for this, we need to compare m of 4 at 2 p.m., which is 4 o'clock. And then we need to find m of 4 and L of 4 and compare them. So m of 4 is people coming in is 512 people per hour. That's the rate in. And the rate out is 230 people per hour. And so it is increasing. because more people are coming in than leaving. Because rate in, M of 4, is greater than rate out. All right. So at what time are people at a maximum? And so they're at a maximum when maximums occur when the rate is equal to 0. And the rate will equal 0 when the number of people coming in minus the number of people leaving is equal to 0, which will happen when the two equations equal each other. Now for this, I am going to use a calculator to find out when they're equal to each other, just because this is really complicated and irritating, and if I recall, the answer is a pretty obnoxious fraction. So I've already typed both equations in, but I did put a minus sign right here, which I don't need, so let me delete this minus sign right here. Okay, so let's go ahead and look at the graph of these two equations. And my window on this graph went from 0 to 10, because that's the time the museum's open, and the minimum and maximum were negative 500 to 750. And so going back to the graph, my first equation is the blue one. You'll notice that it trickles off, nobody's coming in anymore. And we've got this peak of people coming in, but they're equal right there. And I can find that by using the second calculate menu. And I need number 5, intersect. And so my first curve is the blue one, my second curve is red. My guess is, really close to 5, I think. I think we're close to 5. And we are at 5.3888693. And so that looks like a good answer. I'll just leave it there. And so let's go ahead and grab that and put it into my work back here. Okay, so that happens when t equals 5.3988693. And we know that because it's a max, it's going to change from positive to negative because the number of people, if we look at the picture one more time, the number of people leaving is less than the number of people entering after that. And so since it's less, that makes this changing from positive, when blue is greater than red, to negative because red is greater than blue. And that's the important sentence, is that it's changing from positive to negative. And if you want to kind of fix that up so you can see it a little better, one thing you might want to do instead of graphing that is actually graph I meant alpha trace, y2 minus y1, y1 minus y2. And just look at that graph. And so when we look at that graph, you can see that it's changing from positive to negative, which might give you a better idea of what's happening, is that it's changing from positive to negative, so you can make that statement. And that's a really important statement, because even though it's a 0, it has to change from positive to negative. So that's what we need to write down, is that it changes m of t minus L of t changes from positive to negative. At time is 0, there are 25 people in the Met, which is probably the people working there. How many people are in the Met at official closing time at 8 p.m.? And so we're going to be doing an integral. We know time 0. They've given us this extra piece of information, and so we will set up the following situation: 25 plus the integral from 0 to 9.5, because that's when people are coming in, is m of t minus L of t dt minus the integral of people leaving, so the only time when people are leaving without everybody else, L of t to 10 of L of t dt. And it's really important to make sure you're paying attention to the domain here, because my initial reaction was to go from 0 to 10. And actually, I think I went from 0 to 9.5, but I forgot about all the other people who still had to get out of there. And so how many people were still there when they were actually closed? Because there were 25 people there when they opened. How many people were there when they closed? So I'm going to go ahead and let my calculator crunch this out for me. And so I will leave this screen. I don't want to be in mode. I want to quit. So I'm going to go ahead and do 25 plus the integral from 0 to 9.5. And if you recall, my y3 is m minus l, so I can just use that, minus the integral from 9.5 to 10 of y2. And 121-ish people are still there when they close. So even though they're closed and they're trying to get people to leave, they don't all leave. They all sit around, and then afterwards they have to, of course, escort people out of the building. So that's the final answer. We'll go ahead and write that down, which is approximately 120.68015636. I'm just getting in the habit of writing everything down. And so there's that. So we have just a few minutes left in this time. So we've got this box using accumulation and definite integrals and applied index. And here is the information. Given a quantity, y of t and its rate of change, y prime of t, the integral from a to b of y prime of t dt is equal to y of b minus y of a. So the integral of a rate of change is equal to the net change in the quantity. The accumulation equation, y of t equals y of a plus a to t of y prime of x dx. Sometimes y prime of t consists of a rate in and a rate out. Be really careful about this. So you can take your calculator. Y1 is a rate in, y2 is rate out, y3 is y1 minus y2. Way easier to do it that way than try to keep all of them straight already set up. So make sure you take the time to write everything down, and I will talk to you about the checking for understanding in our next video.